Hello, welcome again to our channel. Today, we will still tackle one-dimensional motion, but we will now solve sample problems. For our first sample problems, that is for the displacement, time, and average velocity. Our problem is, in an experiment, a shearwater or a seabird was taken from its nest, flown 5,150 kilometers away, and released. The bird found its way back to its nest 13.5 days after release. If you place the origin at the nest and extend the positive x-axis to the release point, what was the bird's average velocity in meter per second? A. For the return flight, and B. For the whole episode from leaving the nest to returning. Our given is we have 13.5 days, and this is our delta t, and we also have 5,150 kilometers, and this is our position for the release point. And we set 0 as our origin, and this is the location of the nest. And we will find for A, the average velocity of the return flight. This is the average velocity from the release point to the nest. And for B, we will have the average velocity at the round trip. Now, since our given is not yet in SI units, we need to convert this given. So, for the 13.5 days, we need to convert this into seconds. And since in one day we have 24 hours, and in 1 hour we have 3,600 seconds, so converting this one, 13.5 days is equal to 1,166,400 seconds. And this is approximately 1.166 times 10 to the 6 seconds. For the 5,150 kilometers, converting this into meter. So in 1 kilometer, we have 1,000 meter, and this is equivalent to 5,150,000 meters. And this is approximately equal to 5.15 times 10 to the 6 meters. Now let's solve this. For letter A, the average velocity is given by delta x over delta t, where delta x is just the difference between the final position and the initial position. And the final position is the location of the nest, and the initial position is the release point. So we have the nest as 0, and the release point, the location of the release point is 5.15 times 10 to the 6 meters over 1.166 times 10 to the 6 seconds. And this is equivalent to negative 4.42 meter per second. For letter B, we need to have the average velocity of the round trip. And for the round trip, the final position and the initial position are equal. And meaning the delta x here is 0. So our average velocity is 0. For problem number 2, we will tackle about instantaneous velocity. And our problem is, a physics professor leaves her house and walks along the sidewalk towards campus. After 5 minutes, it started to rain, and she returns home. Her distance from her house as a function of time is shown in the figure. At which of the labeled points is her velocity, where velocity is 0 for A, for B, where it is constant and positive, for C, constant and negative, D, increasing in magnitude, and E, decreasing in magnitude. So, for letter A, since the instantaneous velocity is the slope of the tangent to the x versus t graph, so the velocity is 0 when the slope is 0, and it can be found at 0.4. For letter B, where velocity is constant and positive, we need to find where the slope is positive and constant, and this can be found at 1.1. For letter C, where velocity is constant and negative, we need to find where the slope is negative and constant, and we can find this into 0.5. And for letter D, where V is increasing, meaning the slope is positive and increasing. And this can be found at 0.2. And lastly, for letter E, where V is decreasing, we need to find the slope is positive and decreasing as well. So this can be found at 0.3. For the average and instantaneous acceleration, the figure shows the velocity of a solar-powered car as a function of time. The driver accelerates from a stop sign, cruises for 20 seconds at a constant speed of 60 kilometers per hour, and then brakes to a stop 40 seconds after leaving the stop sign. For A, compute the average acceleration during these time intervals from 0 to 10, from 30 to 40, from 10 to 30, and from 0 to 40 seconds. For B, what is the instantaneous acceleration at time 20 seconds and at time 35 seconds? So now, the given is the velocity is 60 kilometers per hour for 20 seconds. And we need to find the average acceleration, and that is delta V over delta t, meaning the change of velocity over the change in time. For B, we need to find the instantaneous acceleration. And since our given is not yet in SI unit, we need to convert 60 kilometers per hour. So in 1 hour, we have 3,600 seconds. In 1 kilometer, we have 1,000 meters. Cancel kilometers, cancel hour, and the 60 kilometers per hour is equal to 16.67 meters per second. For letter A, the average acceleration at time interval 0 to 10 seconds. Again, this is the change of velocity over the change in time. So at time 0 seconds, our velocity is 0. And at time 10 seconds, our velocity is 60 kilometers per hour or equal to 16.67 meters per second. Now, our average acceleration is 16.67 minus this one, 0, over 10 minus 0, and this is equal to 16.67 meters per second over 10 seconds, and this is equal to 1.67 meters per second squared. And this is the average acceleration at this time interval. Next is for the time interval 30 to 40 seconds. So at 30 seconds, the velocity is 16.67, and at 40 seconds, we have 0. So we have 0 minus 16.67 over 40 seconds minus 30 seconds. So we have negative 1.67 meters per second squared. For the time interval 10 to 30 seconds, the velocity for 10 seconds is the 16.67 meters per second, and the velocity for 30 seconds is still 16.67 meters per second. So the difference between these two is 0. So our average acceleration is 0. Lastly, for the time interval from 0 to 40 seconds, the velocity for 0 seconds is 0, and the velocity for 40 seconds is 0. So again, our average acceleration is 0. For letter B, we need to find the instantaneous acceleration at this time. So at 20 seconds, here, our velocity is constant, meaning this is not changing. Our acceleration here is 0. And at 35 seconds, here, at 35 seconds, again, the slope of this line, the slope of this velocity versus time graph is decreasing and constant. So our acceleration here is negative 1.67 meter per second squared. And during this time, this is the acceleration or the average acceleration. Thank you so much for listening, and we will solve more problems for the part B of our lecture video. See you!